Hi everyone, today I'm going to talk about testing in Android, the techniques and the right mindset that we can use to write maintainable tests that can help us to develop faster. Before I begin, let's do a quick introduction about myself. My name is Malvin Sutanto and I'm an Android software engineer at Wonderly. So let's start. So all Android applications, they always start small, but then get complex over time. Features are constantly being added, and nowadays, most of our apps are no longer simple apps that displays data from the network APIs. Also, members come and leave the project throughout the project's lifetime. And if we are not being careful in planning our architecture, it will become very complicated to maintain our project, especially ensuring that regression does not happen in production. Have you ever had that feeling where you ask yourself, can I release this update? Will there be any bugs, or will there be any problems, or will it even crash for my users? So then let's ask ourselves, who should be testing our app? Is it the manual QA team? Manual QA team is good for testing your app because they can follow sets of scenarios and validate the outcomes. However, they can take a lot of time and is not very scalable. Imagine having to test different permutations of types of devices and features of your app. And manual QA team is also unable to reliably simulate edge cases like network errors. And how about engineers? Well, engineers know the app the best, so they can find and identify bugs easier. Well, I agree we as engineers, we need to test what we've built, but is it a productive use of our time? After all, it's still difficult for us to simulate those edge cases. And most importantly, we need to focus on building the app and ship features to our users. And it's definitely not a good idea to let our end users be our testers, as they might stop using the app or leave a bad reviews when they encounter bugs in our app. So why don't people write automated tests in an Android project? Setting up an automated test in Android is quite difficult. And also there are so many different opinions online on how to set up your tests. And it's even harder if you have an existing project that was not set up with testable architecture in the first place. And you feel like every time you make changes to your app, you have to rewrite all of your test cases, and it's actually slowing you down instead of helping you to develop faster. However, there are a lot of benefits with writing automated tests. With a proper test suite in place, we want to make our test scalable. Writing automated tests does take time and can be labor intensive. But the test cases that we've written are going to be run as many times as we want throughout the lifetime of our project. And after all, we're all engineers and we want to automate these mundane processes. So let's do a quick comparison between automated testing and manual testing. Consider this screen of an app where we have an edit text for a message and a send button. When I click the send button, it will send the message inside the edit text into a network API. Consider these three test cases that I've written. How long did you think it takes me to write these three test cases? 10 minutes? Maybe it's a reasonable time. And for testing such a simple screen manually, we don't have to write anything. But how long does it take for us to manually test this screen? Let's say maybe 2 minutes is enough to thoroughly test the app, maybe even take less. But running the automated test that we've written took only about 1 minute. And from these numbers alone, it's clear that writing automated tests takes a lot more time. However, let's say we've made a couple of changes to our simple app and we need to ensure that regression does not happen. so we'll have to retest all of the features again. For automated tests, we just need to rerun our previous tests. But for manual testing, we have to retest everything manually. And what if we make a couple more changes, and more changes, and even more changes to our simple app? And this is a common occurrence in a software project where the product keeps on changing. You'll notice that the time it takes for us to test our app is now so much higher compared to our automated test. If I put it in a graph, it will look something like this. Manual test requires a smaller time investment in the beginning, but will increase rapidly as the number of executions increases. Whereas automated tests requires more time investment in the beginning, but will increase in a diminishing rate. If you're planning on creating an app that can grow in the future, investing in automated test suite is a safe bet for your project. The other benefits of writing automated tests is the ability to reliably simulate edge cases. As I mentioned before, simulating edge cases can be a challenge for manual testing. And automated tests can help us in this area, especially with the proper test doubles, which I will explain later. With test doubles, we can simulate various server responses and error cases and ensure that we've handled them correctly. Automated tests is also good for information sharing. If our test cases have a proper structure, it can also be used as a documentation of our project and can be used to describe the use cases of each screen inside our app. Consider this previous example of our test cases. If there's a new team member who joined our team, they can identify the expected behavior of this screen just by looking at the test cases that we've written. And these test cases can help prevent silos of information where only the engineer who wrote the initial code understands the expected behavior of that particular piece of code. And not only that, test cases that we've written can also be used to aid in code reviews. If you put in proper test cases for your pull request or change list, you can prove to whoever's reviewing your code that you've considered the edge cases and be held accountable for your changes. And this will make the code reviews process much faster. Writing test cases also helps you to write a better software. When you design your code such that it is testable, you'll notice that you start to decouple parts of your code based on its usage. And this will help you to reinforce the single responsibility pattern where one component in your code base is tied only to one functionality, which will consequently reduce the code complexity and make the code base much easier to understand. By writing an automated test, it's also easier to get a feedback of whether the code that you've written is running as expected, and allows you to identify the problems early in the development cycle, which will in turn increase the development velocity. And most importantly, automated tests allows us to make localized changes without worrying about breaking other parts of our app. And this allows us to release updates to our apps with confidence. Now let's see what tools or frameworks that can help us write better tests for Android. In Android, we have a type of test called local unit test. It is located in the test folder inside our module, and it runs in the local machine's JVM environment. Therefore, it is relatively fast, as we don't need to deploy our app into the device or an emulator. However, you cannot use any APIs from the Android framework. The other type of test that we have is called instrumented test, and it is located in the Android test folder inside the module, and it runs on a device or an emulator, and hence you can use the APIs from the Android framework. It is usually combined together with Espresso library to test and validate your UI components. but it's comparatively slow as you need to build and deploy your app into the device every time you want to run your test. And what if you want to use Android APIs in your local unit test so that it can run faster? For that, there's a library called Robolectric that allows you to do just that. Robolectric 4.0 and above officially supports Jetpack. And when we invoke Android APIs from the test code, Robolectric will provide a shadow implementation of those APIs. This Robolectric support with Jetpack is part of Project Nitrogen. It's Google's solution to write once, run everywhere for testing. This allows you to run the same exact test code as both local unit test using Robolectric or as an instrumented test on an Android device. And to set this up, you need to create a shared test folder and add that to the source sets of both your test and Android test configuration in your modules build.readable file. And then you'll write your test code inside the shared test folder and ensure that you've used classes from the Android X test packages. We also have another type of tools called UI Automator, which is a high-level black box testing tools where you give it sets of instructions on how to interact with the device. With the tool, we can give instructions such as clicking a UI element, pressing the back button, changing the device rotations, and so on and so forth. And with UI Automator, you want to test the device as a whole, meaning we can access the home screen, app drawers, notification trays, or even interact with other apps. And another testing tool that I want to show you is called Firebase Robo Test. It works by analyzing your UI structure of the app and simulates real user interactions. With these tools, we want to test flows of an app rather than a single screen. We can guide Firebase Robo Test using RoboScript or Robo directives. And with so many tools available for us, which one should we use for our project? Writing and maintaining tests with all the available tools will take an immense amount of time. We won't be able to write any more features. And this is why it's important to structure our tests properly. And testing pyramid can help us to do that. Testing pyramid is a strategy to guide us on how to split our tests and group them together based on the granularity of the test code. The higher it is in the pyramid, as more components are involved, the higher the fidelity, execution time, maintenance effort, and debugging are. And the lower it is in the pyramid, as the cost of writing and maintaining tests gets lower, we can afford to write large number of tests. Typically, we will have unit tests at the bottom of the pyramid, as it involves only a single method. And as we go up, we'll involve more components and classes, and as such, we'll typically have integration tests in the middle of the pyramid. And eventually, we'll have our end-to-end testing at the top of the pyramid, as it involves all the components inside our app. If I were to give an example for testing an Android app, we'll have unit tests for repositories and utility classes at the bottom of the pyramid. And then maybe fragment and view models tested together as our integration test. And then finally, at the top of the pyramid, we'll have Firebase Robo Test or UI Automator as our end-to-end testing. And how does testing pyramid help us structure our tests? But depending on what we want to achieve with our test, we can use testing pyramid to decide the type of tests and allocate the appropriate amount of effort to be spent in writing and maintaining each type of test. By adhering to the structure of the pyramid, we want to make a balanced test suite that is maintainable and can help us to develop faster. If our test suite is structured properly, we can afford to write less exhaustive tests at the top layer of the pyramid, as we've covered it already in the lower layer of the pyramid. And of course, this is not the only structure that you can use to structure your tests. Neither it is perfect, but it does provide a good starting point for you to structure your tests better. The other key point to consider when writing automated tests is how to write a testable code. And an important element in creating a testable code is to make use of test doubles. Test doubles are replacement objects for classes that you use in production whose behaviors can be controlled during testing. With test doubles, we want to make predictable conditions for our tests. And there are several types of test doubles, but I will touch on the two that I use the most. They're called fake and mock classes. Fake classes are actual objects that use some sort of a shortcut implementation to act like the real class. And here's an example of a fake class. Here I have a user repository interface with one method, getUser. In the fake class implementation, I will extend from the user repository class and return a dummy user object instead of calling a network API or reading from the database. Another type of test doubles is called mock class. This type of class is quite difficult to implement manually, but luckily we have libraries such as mock or mockito. It's a type of class that can respond to a set of method calls whose answers have been defined. For example, we'll now have two methods in our user repository interface, get and delete user. I will use mock library to create my mock repository, and then set up an answer for the getUser method that returns a dummy user object. And we invoke the getUser on this mock repository, we will get a dummy user object. But if we invoke the delete user method, whose answer have not been defined yet, it will throw an exception. Another way to make our code more testable is to create independent and isolated classes. We want to decouple classes such that every other class that it depends on can be replaced easily with test doubles. To do this, we want to use constructors' arguments to pass in other classes, or even better, interfaces, as they are much easier to replace with the test doubles. We also want to avoid static getInstance methods inside our class because they are not easily replaceable. We can also make use of dependency injection framework, such as Dagger, to help us replace the dependencies during testing. Each class also needs to be tested in isolation. In testing interactions for an Android fragment, for example, I will first create a mock navigation controller and then launch the fragment with a fragment scenario to help me test the fragment in isolation independent of the activity. And then replace the fragment's navigation controller with a mock navigation controller that I have prepared. With this, I can easily verify the navigation events inside the fragment using the mock navigation controller instead of letting my fragment navigate and creates other fragments. Another important part in writing a better test code is to make our test stateless. We want our test to have a consistent initial and end state, which means database tables, shared preferences, flags, or values that might have changed during the test are properly reset. We want our test to be stateless because inconsistent state can cause unwanted side effects that will affect the outcome and making our tests unreliable and flaky. One way to achieve a stateless test is to properly set up and tear down each test. And in Android, that can be achieved with before and after annotation. methods annotated with before annotation will be run before any test annotated methods, while after annotated methods will run after the test annotated method is run. For example, when I run this test, it first will invoke the setup method, and then it will execute the first test method inside the class, and then run the teardown method. It will then go back and rerun the setup method, and then the second test method inside the class, and then finally finishing after invoking teardown for the last time. We can also make use of test rule to achieve the same result, and it's very useful if you have a common setup and teardown across different classes. For example, here I have a test scheduler rule that is annotated with a rule annotation, which is a custom rule that I made by extending the test rule interface. In the apply method, I will return a statement object that replaces RxJava's scheduler with a test scheduler, and then execute the test method by calling basestatement.evaluate, and then finally resets the scheduler after the test has been run. Essentially, this will become our setup, test, and teardown blocks. Now you might be wondering, why do I need to replace the test scheduler for RxJava? That is to achieve what we call a synchronous tests. We want to avoid multi-threading during tests as much as possible because they can cause unwanted side effects and therefore flakiness. And also, if you're not careful, it can increase our test execution time significantly, which can be detrimental to our development speed. Many techniques that we can utilize to achieve synchronous test. Like in my previous example, when you're using RxJava, you can replace the schedulers with a test scheduler. And if you're using live data from the architecture components, there's an instant task executor rules that will make live data emit its values synchronously. And if you're using coroutines, there's a coroutine test artifact that allows you to use test dispatchers and run blocking tests and to run your coroutines synchronously. The other aspect of writing tests, which I think is equally important, is called testing conventions. Testing conventions is a set of rules or patterns for writing tests for a project that we can use to guide us to write consistent tests and make it more maintainable. It can be used to describe what type of test we want to write, the test method namings that we need to use, what type of testables we want to use for our projects, and what kind of rules to apply for our tests, and so on and so forth. And each project might have its own sets of conventions that are very different from other projects. But it's very important that everybody in the same project agrees on a single set of convention, because the main objective of these conventions is to achieve consistency. Writing consistent test cases makes them easier to understand, which will allow us to identify breaking changes easier and shorten the feedback loop in the development cycle. This shorter feedback loop will allow you to achieve a higher productivity in your team. And if a project has a maintainable test suite, it will allow others to contribute to the project easier and makes it easier for you to scale your team. Let's see an example of a testing convention. So this is a simpler version of what my team is currently using to name our test methods. We want our test methods to describe the scenarios being tested as if we're explaining it to a non-developer. It shouldn't be too long, as you're supposed to test only one aspect of your app or of your code at a time. And if the name gets too long, maybe it's a good opportunity to break your test into multiple smaller tests. We will also use words like given, want, and then to describe the scenarios being tested. And here's an example of test method where we applied those conventions. We can identify three main parts of the scenarios being tested. That is the initial state, and then the action, and then the expected outcome. When naming test methods, ask yourself whether other people or you in the future can understand what is being tested within 1 to 3 minutes. So next, let's talk about how we can further automate our testing with continuous integration or continuous delivery infrastructure. CI/CD can be used to automatically run tests against the latest version of your codebase. And it can quickly tell us when somebody accidentally pushed a faulty code into the repository. There are different types of triggers that can invoke your CI/CD pipeline depending on the provider. For example, here, a developer will create a pull request in GitHub, and this will trigger the CI/CD pipeline, which will then run the latest test suite on that branch. When it encounters a failure in one of the test cases, it will then send a notification to the developers. Because this runs on a separate machine, your developers can work on other tasks, will then be notified if there's any issue with the latest code. Then there are also other considerations that we need to think about when writing tests. For example, the time spent not only in writing, but also time it takes to run the test suite. A slow-running test suite will have a negative impact on the developer's productivity, and a long CI/CD pipeline can have a financial impact on your company. Also, don't try to aim for 100% test coverage, because your code coverage might not show the quality of your test suite. When you aim for test coverage, you'll find yourself writing a useless test just to achieve that coverage number. Instead, focus on the main use cases of your app and ensure that they are properly tested. And even with all the automated tests that we have in place, it doesn't mean that we need to stop manually testing our app. Manual test is still good to find errors that are not obvious and easy to catch when you write automated tests, such as user interactions or animations. And manual test is also good to catch unhandled edge cases or incorrect use of testables. Now I want to share my team's experience when we migrated our app into a testable architecture. The first step that we took was to understand the pain points in writing tests in our code base. We had test cases, but they were difficult to maintain. They were quite complex and different parts required different test setup. There were also a lot of magic code to forcefully replace the dependencies with a test double. And what makes it most difficult was that our classes were so heavily coupled that we were not able to test them in isolation. And rewriting our app from scratch is not possible, as it will take too much time. So then we created a plan where we defined what type of test we want to write and how are we going to maintain this type of tests. We decided to use testing pyramid, like what I've described before, with methods of view models, repositories, helper classes, utility classes tested as a unit test. And then fragments and view models tested together as our integration tests. And then finally, we have Firebase Robo Test as our end-to-end testing. We then also decided on several testing conventions, a descriptive test method name, like what I explained previously, Then we also decided that our development branch is always ready for a release, which means every pull request that is going to be merged will have to have an added or removed test code. We also make use of a lot of third-party libraries to help us write better tests, such as testing support library from Jetpack, Robolectric, Mock-K, and also custom JUnit rules like what you've seen previously. Then, as I mentioned before, full rewrite of our app is not possible, so we decided to introduce testing into our codebase gradually. First, we decided to move all of our existing code into a module called legacy module, and then exclude this legacy module from the code coverage report. And then, for every feature that we want to improve or add into the app, we will create a new module for that feature, and then write a new code or take the code from the legacy module and then refactor it to be a testable, and then add the test code and code coverage around that module. Then we continue to do this for every feature that we want to add inside our app. And with this, the amount of code in our legacy module will keep on decreasing, and we will finally be able to remove the legacy module altogether. As for our CI and CD infrastructure setup, we use a Circle CI and Fastlane to allow us to run different build and tasks configurations for different triggers. For example, each pull request that is made into our repository will run local unit test on the CI machine and instrumented test on Firebase Test Lab. And then coverage analysis will be performed using Jacoco based on the coverage report of these two types of tests. And then it's fed to CodeCoff to generate the overall code coverage report. Then we also have another type of triggers that runs our end-to-end testing Firebase Robo Test every morning. The reason why we split these two types of triggers is because running all types of tests for a pull request will take too much time and will decrease our productivity. And with this strategy in place, we were able to reduce monthly fatal crashes by 65% and achieve a code coverage of 60% for all new and migrated code within a year, while also consistently releasing new features and updates to our users. To summarize what I've talked about today, properly structured and reliable test suite, even though might require a lot of effort, can help us to develop faster and make teams and projects scalable. There are many tools that you can use to write tests in Android, but it's important to discuss and develop the right strategy and conventions that allows teams to create maintainable test suite. What I showed you today is just an example of what we did. Every team might use different testing tools, frameworks, or testing conventions based on their use case. So try to design your code to be testable as early as possible, or create a migration plan if you have an existing code that you want to make testable. Remember that writing test code is a continuous process, and software project will always get more complicated. So it's never too early to start writing your tests. And that's all I have for today's talk, and thank you.